Welcome to this video on multilayer perceptrons, or MLPs, in neural networks. Let's dive into the core concepts and practical applications of MLPs. Here's the outline of what we will cover today. First, we will define feed-forward networks and MLPs. Next, we will explore forward propagation and backward propagation. Then, we will examine loss functions and their impact on training. Finally, we will show you how to implement an MLP using Python and scikit-learn. A multilayer perceptron, or MLP, is a type of feed-forward neural network. Unlike single-layer perceptrons, MLPs have at least one hidden layer of neurons. This allows MLPs to handle both classification and regression tasks. Connections in MLPs flow in one direction without cycles. Training an MLP involves two critical steps: forward and backward propagation. Forward propagation feeds inputs through the network to generate predictions. Backward propagation adjusts the network weights to reduce prediction errors. Back propagation uses partial derivatives of the loss function to update weights. Loss functions measure the error between predicted and actual values. For classification, hinge loss and log loss are commonly used. For regression, mean square error, MSE, and mean absolute error, MAE, are popular. Loss curves help diagnose whether a model is overfitting or underfitting. The provided Python code snippet demonstrates how to implement an MLP using scikit-learn. It initializes an MLP model with two hidden layers and ReLU activation. The model is trained on the dataset, and its performance is evaluated on training and test data. This makes applying MLPs to real-world datasets straightforward. Loss curves are essential for diagnosing model performance during training. Underfitting occurs when both training and validation loss remain high. Overfitting is indicated by validation loss increasing while training loss decreases. An optimal model has both loss curves converging to stable, low values. To summarize, MLPs are versatile tools for classification and regression tasks. Forward and backward propagation are essential for training these networks. Loss functions and curves play a crucial role in diagnosing model performance. Scikit-learn simplifies the implementation of MLPs, making them accessible to all. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.